paper is entitled Dialogism meets language models for evaluating involvement in CSCL conversation, and Maria-Dorinela is going to present it. Basically, in this paper, they propose a method to evaluate students' involvement in online conversation. So I found it very interesting, I have to say. So I will leave the floor to Maria-Dorinela.
Hello, everyone. I am Maria-Dorinela Dascalu. I'm a PhD student from Polyphony and University of Bucharest. And I'm going to present the paper called Dialogism meets language models for evaluating involvement in CSCL environments. So online learning environments include learning resources and technology, means of teaching, modes of learning, and connections to societal and global context. It also includes human behavior and cultural dimensions. Technology plays a really important role in the design of learning environments by improving educational processing, reducing the time to perform certain tasks, increase the availability of resources, and providing an ecosystem that stimulates creativity and the desire to learn. During the COVID pandemic, the need of such learning environments has dramatically increased. The transition from physical to fully online was really drastic, and the adaptation was required in a very short amount of time. Since everything moved online, face-to-face classes, discussions moved to forum, chat, and of course, a lot of video meetings. In conjunction with the adoption of learning environments, computer-supported collaborative learning has become increasingly used in educational context due to its synergic effects among peers. Learners can share their ideas and opinions, learn from each other, while having access to a wide range of materials. The most common used communication method in CSCL environments are forums and chat, and this is because they offer learners the opportunity to work together to solve problems and ask for help if they need. Using these methods of communication, students collaboratively build knowledge and share it among all participants. In CSCL environments, collective and individual learning processes intertwine one with another and create collaborative knowledge. From tutor's perspective, analyzing the resulting conversation is a really time-consuming task. Therefore, automated processes or tools that analyze conversation and evaluate collaboration between participants have become a necessity. Dialogism was first introduced by Bakhtin as a psychological theory, focusing on the idea that everything is a continuous exchange and interaction between several voices. Voices represent different points of view that spread throughout the discourse and influence it. Dialogism is also considered a paradigm for CSCL, where voices take the form of concepts or events that are propagated throughout the conversation by participants who share convergent or divergent perspectives. Voices found in participant contribution from CSCL conversations interact one with another and influence each other. Polyphony is a corpus intent of dialogism. It has a background in music and knowledge construction and collaboration in which words and utterances are linked in parallel, threads which interact similarity to voices in polyphonic music. Each participant keeps their individuality, personality, but they also collaborate to achieve a common goal, trying to solve dissonance. Polyphony is considered a model of collaboration and interaction. Based on this, our goal was to introduce an automated method grounded in dialogism to evaluate student involvement in chat conversation based on semantic chains identified using the BERT language model. While BERT is a state-of-the-art language model that considers contextualized embeddings, solving NLP tasks is now a two-step process. One, train on a large unlabeled text corpus, and two, fine-tuning this large model to specific NLP tasks. BERT is a transformer-based deep neural network that uses a mechanism of attention, which learns the contextual relationship between words from a text. BERT builds contextual representation of words by stacking multi-head attention layers. For example, in this picture, the input was, "Do represents a SLERD conference. The conference is super friendly." As you can see here, the model learns repetition. For example, conference to conference. Also, Dory and SLERD are split into sub-words tokens because of the limited vocabulary size in BERT, so they don't exist in BERT vocabulary. The associations are not perfect, but we can fine-tune the model. Our method uses contextual information captured by BERT to find lexical links while only considering the attention weights from different heads. The resulting model generalized to multiple relations, including repetitions, semantically related concepts from WordNet like synonyms, hypernyms, as well as pronominal resolutions. By combining the attention scores between words, word pairs are merged into connected components that denote emerging voices from the discourse. In order to build the semantic chains, a dataset derived from the TASA corpus containing potential links between words in a given context was automatically generated given some simple rules. For example, repetitions of words with the same lemma, synonym, hypernyms, and coreferences identified using spacing. In total, 49 million word pairs were extracted, out of which around 20 million were positive examples. This data set was used to train a model on how to effectively combine the different attention heads from BERT using a multi-layer perceptron in order to identify semantic links. The trained model was used to identify all semantic chain links in a conversation while accounting for all pair of words. Now, the semantic chains computed using BERT were used to assess the involvement of students within the conversation. The chains cannot be directly used to build a prediction model, so we define a list of features based on the constructed chain. Part of the features are inspired from Lex1 and are generally applicable to lexical chains, whereas the remaining ones are chat-specific. Here in this table, you can see the general features and also the chat-specific features. The chat-specific features are designed to capture the interaction between participants based on the semantic chain. Each semantic chain represents a distinct topic discussed. Therefore, part of the features consider how chains are initiated by a participant. Even if a chain is only included in the contributions of a single participant, it still remains relevant for measuring participation because it denotes active involvement of the participant. Regarding the corpus, our analysis was performed on chat conversations. The corpus consists of 10 chats selected from a corpus of 100 conversations, which were scored by 4 raters. The conversations took place between 2 or 5 undergraduate students studying computer-human interactions to debate on the advantages and disadvantages on specific CSCL technologies. During the conversation, each participant has an advocate of a technology and try to convince the other participants of the advantages of their technology. Afterwards, all participants had to come up together with a new solution which incorporate the discussed advantages. In terms of results, we generate interactive visualizations to highlight both longitudinal propagation of voices and transversal overlap of semantic chains between participants. Also, several machine learning algorithms were tested using the previously introduced features to evaluate the performance of semantic chain in assessing involvement of students within the conversations. First, visualizations highlights the longitudinal propagation of voices. Words are colored according to the semantic chain to which they belong, as well as the corresponding links. Each row represents an iterance enriched with details like identifier, timestamp, participant identifier, which was incrementally generated for anonymization. In this segment of conversations, 4 semantic chains were identified. First, concepts related to documentation, pink color, and you can see words like documentation, document, documents. Second, concepts related to text-centered CSCL technologies like forum, chat, share. I think it's the green color, let's say. It's not really agree, but let's say green. Green. Third, concepts related to CSCL technology that integrate video, for example, wave meetings and video, and you can see the blue color. And 4, concepts related to actions facilitated by technology, and for example, here you can see support, the red color or orange. The identified semantic chains reflect the theme of the conversations, more specifically the advantages and disadvantages of the CSCL technologies considered. The transversal visualizations show how underlying concepts are uttered by different participants. The words are and the links are colored the same according to their corresponding semantic chains, and colors differ between the visualizations because they are randomly selected. So we tested several machine learning algorithms in order to evaluate the performance of semantic chains in assessing the involvement of students within the conversations. Since the dataset contained 10 distinct conversations, a 10-fold cross-validation was performed. 2 different grades, namely participation, which means reflective of active involvement, and collaboration, which means interaction between peers, manually scored between 1 and 10, were predicted with 2 separate models. In terms of model evaluation, this table shows comparison between different models for the 2 tasks, participation and collaboration, by taking into account the mean average error. Lower mean average error value denotes better models that are closer to the average human ratings. The human performance obtained on this dataset shows mean average error lower than 1 out of 10, denoting that readers were close one to another. Random forest is the most predictive model, reaching mean average error of 0.55. Lowering the number of generated trees has a beneficial impact on performance. Overall, the machine learning model seems to better capture the average score of the raters, having the advantages and of generalizing across participants.
Just a couple of minutes.
Okay. A subsequent analysis was performed to understand the importance of each feature for the 2 tasks. The most model from the cross-validation for each task was trained on the whole dataset. Higher value denotes more relevant features, and the sum of all Gini features importance score is 1 for each prediction. As you can see here, the ratio of chains denoting the coverage of semantic chains used by participants in relation to the entire conversation. Continuations also reflective of links between 2 different participants coupled with count and ratios of change covered by the participants are the best predictor for collaboration. In conclusion, we introduced an automated model for evaluating student involvement in chat conversation using dialogism as a paradigm and language model for identifying semantic chains. Our method relies on contextual information captured by BORD to identify semantic chains. Longitudinal and transversal visualization were generated to highlight occurrences patterns of semantic chains. A list of features was introduced containing both general metrics applicable to the constructed semantic chains and chat-specific features, and several machine learning algorithms were tested using the defined features, and the best model based on random forests were capable to predict participation and collaboration. In terms of future work, we envision applying this dialogical model on other datasets and performing related analysis. For example, dialogism can be used to monitor student engagement in online courses, and the introduced features can be employed to predict dropout in course grades. Even more, by evaluating the semantic chains, Discussions and corresponding contributions can be cataloged as being course-specific, administrative, or off-topic in automated guidance mechanisms, and an automated guiding mechanism can be introduced while targeting creativity stimulation. And that's all. Thank you very much.
Thank you very much. I have a question for you. I didn't really get from the paper if you already adopted this model in a course. I mean, during its running, during its delivery, and so. But in case, even if you still haven't done so, it would be nice if you could elaborate a little bit more in terms of implications for the teachers, for the tutor. I mean, at the beginning of your presentation, you mentioned the fact that analyzing this conversation can be very time consuming for the tutor. And I totally agree with you. So for sure, an asset of this model is that it should allow to save time. But how do you imagine the tutor to use this model in a running course? Can you elaborate a little bit on this? And then I see there is also another question, but okay, please go ahead, Dorinela, and then I will give the floor to Carlo.
Yeah. No, for the moment we didn't apply this on a course and in real time, let's say. How I see this is these views and these predictions can be used as a plugin, for example, for Moodle or for any forum chat that teacher uses to talk to the students, and provide insights in real time about how students collaborate, which students are more active, which students don't respond, to see the interactions between them and the discussions topic. If the topic changes a lot, for example, we have to discuss about, topic A, but after 5 minutes, we talk about different things like movies, and the discussion is...
Yeah.
So I see this as a plugin for Moodle, for different tools that teacher use.
So in with a monitoring purpose rather than an evaluating one, or both of them. I mean, monitoring.
Both.
Okay.
Yeah.
I see. Thank you very much. So Carlo, the floor is yours.
Very quick question. The first one is, I would like to know if you can, you can make a difference between polyphony and cooperation. This was my very short first question. And the second one is, in principle, the tool that you developed is a very, could be a very useful one. But I wonder if now you can really catch the collaboration among students, since most of them are exchanging messages on WhatsApp, for example. So what do you think about?
Regarding the first questions, the connection between polyphony and collaboration,
not collaboration, cooperation.
Cooperation, okay. Cooperation. So the polyphony give us the musicality, let's say, of the conversations, and how the topics and how the ideas, how the opinions spread through the conversations. And if there are some,
if I may, so from an engineering point of view, polyphony can be viewed as a model of discourse. So that's what we're trying to do, to identify links between different segments of the discourse. From that, we extract features, and using those features, we can predict lots of things. So in this paper, we predicted collaboration. Cooperation could be also interesting because, yeah, but as an effect in chats, collaboration was more interesting. But we can also assess, for example, text cohesion. We can use these links to potentially predict more features or more dimensions of the discourse. And what you said, Carlo, that's the biggest constraint, because we can't actually force students to use a specific channel. So it's really tricky to consider WhatsApp or different channels, because whenever we ask them, for example, use this channel, academic channel or Teams, they most likely they have a backup channel in which they discuss more, and we can't assess that. But for example, what we want to do, and that's a main idea, for example, is to use the official forum discussions, for example, in our Moodle, and to predict if there are cases in which, for example, we've got off-topic discussions, or if we can timely intervene. And we see that, for example, there are some students. I was one of those students who never had any contributions on the forum. And potentially I may be flagged by the systems because I'm not participating in the forum discussion, so I may be an outlier. But otherwise, to simply give hints to the professors that, okay, there are no discussions, or discussions are off topic, and to have an intervention from them. So human intervention, it's only a supporting student.